from? Bold press. How many are here from bold press? How many students who here? Have you signed already?
Okay. Up to now,
Huh?
up to now,
Huh?
up to dinner.
I'm joking. Who's this person now? Siam Bhadra. Absent or will come late. Okay, fine. How many are here from Gold Crest? Only one? For that, we'll know each other. And we'll sit together. To play mischief. He's my grandson. Do you know that? This boy is my grandson. Huh? He told you? Okay, fine. And your teacher, your 8th standard teacher, what is her name? No, I'm talking about your Bodhar school teacher. Who? Yeah, I taught her when she was in college. Okay, she's my student. Now you're from which school?
Anchor.
You?
St. Mary's St. Mary's
St. Mary's Copenhagen. Ah, yes, that is there. That has the ICSE. Right. Okay, fine. Then, from? Not. Oh, not quite. Yes, I know. You know. Okay, you? Sadhu Vaswani. This side here. Sanpala, yeah. And you? Same. Okay, so you know each other. Anyway, I'll introduce myself to you. I'm Dave's grandmother, and I will be teaching you chemistry as well as English. Okay, so MA, you must have got that MA. Okay, so that is it. I hope now every time you come for my class, I expect you to bring your textbook and your volume. Yeah, okay. Okay, let's come from. You're going to school?
No.
Not point. And you? No. You're also going to not point. Okay, fine. All right. And then you have to sign here. Sign this. I sent down. This and down this.
No, I am just for them.
Actually, you come to demo class. Yes. Okay, fine. Fine. You too, no? I know that that's very good. All right. You are the teacher. Right. So, I will be coming teaching you, as I said, for chemistry as well as for English. And what I'm trying to tell you is each time you come here for your class, I expect you to bring your textbook as well as your volume. Okay? Now, then also you have to keep a book specially dedicated for chemistry. I don't want the front page chemistry, then in between maths, then in between physics. No. One book for my chemistry. Is this clear? And then I have the habit of checking your homework. I sit down and I check your homework. So homework is to be done. Otherwise, I'm going to scream at you. Scream. Okay? Don't judge me by the gray hair. Because I've got a lot of energy in me and I've got a lot of experience also. Ask him. He has had the receiving end of my hand. Okay. So now, have you started any subject, any chemistry? Very first language of chemistry. Okay, fine. So let us talk about the very first language of chemistry. First of all, I'm going to ask you a number of questions. You've got to answer that. Okay? Why do we have to study chemistry? Or why is chemistry important to us? Or what does chemistry tell us? Okay? What do we know about chemistry? Why do we have to learn chemistry? Give me, now you are all, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 answers I want. Why do you have to learn chemistry? Or why is chemistry important to us? What does chemistry teach us? Any of these answers.
Because we can research.
And then?
We can research about the things.
Loudly, I'm deaf.
We can research.
You can't research what?
We can research the things in chemistry, like the.
So you feel that chemistry helps you to research. Research what?
Research the chemicals and the vaccines and medicines.
Okay, yeah.
Exploration of new elements.
Okay, fine. Then,
New use in the field of industry.
okay,
To study about new chemicals.
okay, you,
We understand the different gases and their properties.
all right, you,
Understand ourselves to the atomic
atomic level, okay, then,
Understand about the building blocks of matter.
building blocks of matter. Okay, remember that? Yeah,
We get to know about the atomic weight.
that's what. Okay, fine. You.
It's like we can produce medicines.
Okay, then something you have to say. What does chemistry teach you? Or why do you have to learn chemistry? How does chemistry help you in life? Yes, I want to answer. Yeah.
Like we can understand many things from chemistry and harness its power to make new technologies.
Okay, you want to put your hand up? No. Can you
It helps us to learn more about reaction.
more about
Reaction.
and reaction? Okay. See, all said and done, chemistry helps you to learn something more about matter. More about matter. Matter in the form of technology, in the form of chemistry, in the form of equations, in the form of medicine, in any form. Gases, liquids, whatever, matter. So chemistry helps you to study more about matter, right from the initial stage until its complex stage. Is this clear? That is what chemistry helps us to do. First of all, then to understand what chemistry, how chemistry works and teaches us matter. What is matter? What is matter? What is matter? Have you heard of this word before? Why? What is it? Why do we call this matter? Do we call this matter? Yes, why? Because loudly, because it's a solid. Okay, what is matter?
Matter is something which occupies space and has mass.
Okay, you
The number of atoms.
okay. And say yeah. You tell me.
Matter is anything which occupies space, have mass, and can be perceived by our senses.
Yes, can be touched, tactile. It can be touched. Okay. So matter is something that occupies space, it's got density, it's got volume, and it's got rigidity. Okay? Alright, fine. And most important of all, it can be touched. Alright. Now, you know fully well that matter, the smallest part of matter is called
Atom.
element. The smallest particle of matter is called element, and an atom is a part of the element. This is just that you can understand, very clear. Okay? Atom is the smallest part of the element. Matter, element is the smallest part of atom. Now, I have got a piece of matter, say a stone, and I break it, tiny particles. And I say, this is the particle which is the smallest particle. It is an atom. Okay? And you will say, Miss, why are you calling it an atom? I can break it still further. Sure, you can break it still further. But when you break it still further, there's every chance of you destroying that atom, okay, and converting it into a substance having properties different from the properties from which it was obtained. It was obtained from stone. You broke, and still broke it and went beyond, and either that matter evaporated and went away and you lost it, or it got converted into something else. So the smallest particle of the element, which has its properties, which maintains its properties, is called the atom. Can you get particles smaller than atom? Yes, but you will not get the original physical and chemical properties. It's a brand new substance. So that means you destroyed the original atom. The smallest particle of an element which has all its properties, physical and chemical properties, of the substance from which it is obtained, that is called an atom. An atom is not independent, meaning what? It cannot live alone. It cannot stay alone. It has to combine with another atom of its same kind or of another kind to become stable. Most of the atoms follow this pattern. But remember one thing, there's always exceptions to the rule. If I say, all of you keep your mouth shut, most of you will keep your mouth shut, but one person will have to be breaking that rule, exception to the rule. So you have exceptions to the rule even in chemistry. So, and those atoms which do not follow this rule, that they have to combine with another atom to become stable, is called, they are the atoms of inert gases. Inert gases. Okay, what are the inert gases? They are called noble gases. They're also called noble gases. Noble gases, okay, and they are of what? Which are the? Do you all know? Neon, argon, helium, okay, krypton, xenon, radon. Okay, so these are the atoms of rare earth elements or of rare gases or of inert gases or of noble gases. All these names belong to them. Okay? Because they have got already stable electronic configuration. That I will tell you what was configuration. Two big words there. We come to know when we come to atomic structure. Right now, these can live as single atoms. So they are called monoatomic. Monoatomic. What are monoatomic atoms? Atoms which are capable of living independently, okay, are called monoatomic. All atoms are not monoatomic. Why? Because they cannot live independently. However, you have only the atoms of rare earth elements or inert gases or noble gases which are capable of independent existence because they've already got their complete electronic form. They're stable. Just say they're stable. Now, why are they called noble gases? Why are they called inert? Inert means they don't react. They don't bother to mix around with anybody because they're already stable. They don't want. Okay, they have nothing lacking in them. So therefore, they don't want to mix around. And they're noble. Noble people don't mix around anybody. They just are different. They just don't interfere or interact with anybody. Noble people, the noble gases. They do not interfere, they don't interact, they are inert. Inert means not chemically active. So far you got it? No. So therefore we have got monoatomic, and these are all monoatomic elements. But when you have a particular atom of any element other than these, they are not independent. They're very unstable, and in order to attain stability, they've got to combine with another element of its own kind or of another element, okay, to form what we call is a molecule. Okay, so sometimes you have got, say, nitrogen plus nitrogen giving you N2. This is an N2 molecule. And since it has got two atoms, it is called diatomic molecule. Two atoms. Similarly, hydrogen H plus H, H2, hydrogen molecule. Oxygen O plus O, O2, diatomic. Now you have got also O plus O plus O, which is giving you O3, this ozone. So this is now what type voucher? What type of molecule would this be now? Very good. Why triatomic? Is she correct?
Yeah.
Why?
Because it has three atoms.
Three atoms. It's got three atoms in the molecule. This is the molecule. It's got three. So this triatomic. Okay. So you have got now P4. That is P plus P plus P plus P. That is said to be poly, no, tetra. Oh, be specific. Poly is correct. Poly means many. But if I have to say be specific, then it is tetra. Correct. Poly is correct. Be specific. Tetra. This is tetra. Tetra meaning 4. Tetra meaning 4. Oh, you have got S8. That means S plus S plus S plus 8 times sulfur molecule. That has got 8 atoms in one molecule. So that is a octa molecule. Octa molecule or polymolecule. Octa molecule. Okay. So now you understood what are atoms. When they are unstable, they will automatically become independent. How do they become independent? They are not independent, but then they become independent. How? How do atoms become independent?
After taking the one.
After? My God, where did I use that word and sentence? Did I say something like that? What parts are we talking about here? From where did you get this? I don't know anything about chemical bonds. I never mentioned anything about chemical bonds here. I only told you atoms are not independent, but they become independent. How? How do atoms become independent? You,
Using a gaining an electron.
you,
By adding with another atom to form a molecule.
simple. That's what I'm telling you. They're adding on to each other and forming molecules. What did I tell you all these 5 minutes? You're not paying attention. Did you understand what I said? Then why were you not able to give me the simple answer? They just combine with another element. They combine with another atom. It could be another atom of the same type, or it could be hydrogen. Suppose you say carbon plus oxygen, giving you carbon monoxide. This is two atoms giving you a molecule. It could be the same, or it could be different elements, but it is now a compound. Do not do what you're doing, my dear. You lose out on what I'm teaching you. I want simple answers. They just combine. Whether they combine with elements, with atoms of their own type, or they combine with atoms of a different type. See what happens here. Suppose you're individual atoms. Would you like to stay like that? No, eventually you will go and form a group. I want to go and connect with him. He could be a polar school, or he could be a north point. So you could combine with north point, or you could combine with polar. Same or different, but you want to stay together because you want to feel comfortable. You want to feel balanced. As long as you're alone, you will feel uncomfortable. The moment you combine with somebody, be it of the same school, be it of the same sex, could be two boys, or a girl and a boy, irrespective, you are comfortable. Why? Because you've got stability. So don't be under the impression it happens only with atoms. It happens with us human beings. We all want stability. We don't want to live alone. Yes or no? So now you understood that? Either we form just two friends, or we could have three people in our group, or we could have four people, or we could have 8 people. Big group of friends that we want to be together. Is this clear? Now, one part. Don't open your book. Only I have the right to open my book. Now, so therefore now, if they combine with each other of the same type, you get this type of a molecule, or you can get an atom like this, plus an atom of chlorine, and you're getting sodium chloride, which is now a molecule of a compound. This is a compound. This is a compound. Is this clear? All right. Now, if it is of the same type, it is a molecule. When you take two atoms of different types, you get a compound. This is a molecule of a compound. Okay? This is a molecule of an element. Why am I calling this a molecule of an element? Why am I calling this a molecule of a compound?
Because it is made of two molecules.
It's made of?
Two molecules of different.
This is made of 3 molecules.
No, but they have different types.
Of different types. And here it is of the same type. Follow now? Got that clear? Is this clear, all of you? Okay, now, when we say that a particular element is combined with another element, or with itself another element of the same, another atom of the same type, we write down the full names. But it's not possible to write sodium, S-O-D-R-U-M all the time. Okay, so therefore now we have to write down the short forms.
Yes.
Those short
Symbols.
they're called symbols. If they are short forms of an element, it is a symbol. If it's a short form of a compound, it is a formula. Okay, so you have to say now short form of an element. Short form of an element is called symbol. Okay, then short form of a compound is called a formula. So, in the case of the short forms, how did they arrive at the short forms of a particular element? They gave them the names and they gave them the names and all. And they found that so many of them had the same starting letter. Sulfur, sodium, silicon, all S. So therefore,
First of all, alchemists will.
alchemists are big words, too big words. We want something simple, absolutely simple. So all
They take from the first two letters from the English
Yeah.
name or their Latin.
So they found out various ways and means of getting a name. Okay? It was trial and error. Okay? So if they say sulfur is capital S, then sodium again S, then silicon again S. So how do we do it? Then they said, no, we won't talk about the English name, that's it, the Latin name. Okay? So sodium was called natrium. Okay? So sodium was called natrium. So from a Latin name, natrium, it became N. N. So N was neon. N was neon. Okay, again they were hitting a wall. Then we take another letter. Then A. They took the second letter. So that is how by trial and error. If the Latin name was not, or it was common, the letters were common, then they said, no, we'll take the, see, for the color of the element. For example, gold. Gold is got the color of sun. And in Greek, sun is called aurora. So aurum. Okay, that's how gold got its name. A. They said no. Again, A will be say argan, or it could be say Argentine. So they said no. Again, we take A is out of the question. We take it AU. That will be gold. Let's take silver. S silver. S is sulfur. S is silicon. And they said, oh God. Shall we take the color? Again, it is white. No, they didn't want. Then they took it, they called it Argentinum because it was discovered in Argentina. So if it's not the color, if it's not the Latin name, if it's not the English name, it is not, it was taken from the country from which it was discovered for the first time or in large quantities. For example, copper. Copper is C. Carbon is C. Okay. Cobalt is C. So what are we going to do? Which C could be given to which letter? So since carbon was first discovered, carbon got C. What about cobalt? And if the cobalt is like pink in color, okay, then we will say CO. Take two letters that will assign to cobalt. What about copper? Again CO. COP. Then therefore they took it from the Latin. No, they took it from the place from which it was obtained. That was Cyprus. So it was called Cyprus. Cyprus is in Greece. So copper was found there. So it was called Cyprus. It was called Cyprus. So Cu. Now, when you have only one letter, say S for sulfur, O for oxygen, H for hydrogen, okay, N for nitrogen. That one letter is always capital. The first letter is capital. Okay, this is nitrogen. Now we want sodium. Sodium is natrium. So we took natrium. Natrium. So they took natrium. Now, they took first two letters. So then they did not put it as a capital letter A. Because when you put a capital letter A, it means a brand new element. Is it a brand new element? No, it is from the same name. So when they took two letters, the second letter becomes small. Do not write the second letter as a capital letter. Only the first letter is capital. Okay, so you have, say for instance, you have cobalt, Cobalt. So it is CO. Is it CO? No, this is wrong. It is CO. And if you're taking CO, then this is carbon and oxygen. Whatever. But it is carbon, there are two elements here. One minute. There are two, huh? You look at me and you pay attention to what I think. I will get help when you go home. I'll get help for you when you go home. You bother about the TV. So CO is nothing else but two elements. Why am I saying it's two elements? Why am I saying this is two elements?
Because we write the second letter as capital, it will like become
Two elements. Two elements, correct. If your second letter is a capital, that means the second one is also an element. But if the second letter is small, it belongs to the same element. Have you understood? All of you, I will not repeat this. Any difficulty? Can I go further? So now, so you got this now? Now when you talk about, okay, if we have got, say for instance, a particular symbol or formula, this is symbol or formula?
Sodium.
Is it a symbol or a formula?
Sorry. No, I just.
Pardon me?
No, I just didn't hear you.
I'm talking so loudly. I thought I was deaf. You're also deaf. You're not paying attention. That's why I caught you. You're looking at me, but your eyes are somewhere else. I can spot out immediately someone who's not paying attention. That's why I caught you. And right enough, I was right. So what is this? This is a symbol or a formula?
Symbol.
Why?
Because it is just a single element.
Because of a single element, correct? Now what happens is, so this is a symbol. Now this symbol Na tells you that there is only one atom. It's only one atom, okay? The element here has got only one atom. Then it tells you the name of the element. So Na tells you the name of the element, which is sodium. Na like this tells you also that it is only one atom. And also Na like this will tell you that there are 14 parts of sodium present here. Means its atomic weight. This is the information you get when you write down a symbol. That is just general information. It is not coming for your exam. What is the information that is given to you when you write down a symbol? It tells you the name of the element. It tells you that it has got only one atom. And it also tells you the atomic weight, which you have to learn by heart. That's 14 here in the case of sodium. Okay? Not for 11 in the case of sodium. Now, if you're talking about, say, for instance, H2O. H2O. Now, H2O immediately will tell you that this is the formula or element.
It's a formula.
Or a symbol. It's a formula. Why?
Because there are two elements.
There are two elements, correct?
Hydrogen and oxygen.
Okay. Now, what does this tell you? This H2O tells you that it is one molecule of water. Why? Because there's one here. Understood. It's understood. If there was two here, then it tells you that there are two molecules of water. Correct? In the two molecules of water, okay, it has got two atoms of hydrogen and one atom of oxygen. Not molecules. This is H2O tells you that it has got two atoms of hydrogen and one atom of oxygen. Correct? And it is only one molecule. Correct? If it was two molecules. If it was three molecules. Then of course, you can also calculate the weight of water. You know the atomic weight of hydrogen? Multiply it by 2. Add it 2 because it is 2 here. And add of oxygen 16 and you'll get your 18. So this is the information you get from a symbol and you get from a molecule. Clear? So suppose you have a compound like this, Na2CO3. What does this tell you? Is this a symbol or a formula?
Formula.
Why?
Because there are two different elements.
There are?
Two different elements.
You have 2 there are. So carefully because I will come and crush you. Oh, from 2 it became 3 now. Then if I crush you again, it will become 4. Which is the 3?
Sodium, carbon, and oxygen.
Okay. What information do you get from this?
It is one molecule of sodium carbon.
Correct. Actually, is it correct? No? Why not?
That is the atom.
He said what? Pay attention. He said one molecule of sodium carbonate. He said one molecule of sodium carbonate. You're not paying attention. Second time I caught you. Next.
It has 2 atoms of sodium and 3 atoms of one atom of carbon and three atoms of oxygen.
Correct. So you have to calculate the molecular weight. Sodium is what now?
11.
Into 2 plus carbon 12 plus oxygen 16 into 3. 16 is a 48. Add up and you get the molecular weight. Okay. So this is the information we get from the molecular formula. Any difficulty? Feeling sleepy, all of you? Are you feeling sleepy? I will make sure that you don't fall asleep in my classroom. Is this clear? Okay. All right. Now, what is the meaning of valency? Have you heard of this word valency? Yeah.
Products should be equal with the number. Sorry, the reactants should be equal with the products.
Yeah.
The combining capacity of
The combining capacity of the atom of an element. Valency.
Valency.
Ah.
But you were asking what the valency
Valency, not balancy. Which word in English called balancy? Huh? From where? Valency, not balancy. There's no word as balancy. Actually, what you were saying something? Not with different. Okay. Okay. Right. See, actually, there are two definitions of valency. The old definition and the new definition. According to the old definition, they tell you the combining capacity of one element with hydrogen or with oxygen. Okay? The modern theory says it depends upon how many electrons are given out or accepted to form to help the combination to take place, to help the formation of a compound. Okay? Mainly today we focus on the modern theory. All right. So, what is valency? It's a combining capacity of an element, either with hydrogen or with oxygen only two elements, hydrogen or oxygen. However, the modern theory says it is the number of atoms that are donated or the number of electrons that are donated or accepted in order to get stability. Now, what is the charge of an electron? Huh? Negative. So, in the case of group 1 elements, group 2 elements, group 3 elements, they give out electrons when they're combining or they accept electrons? They give out.
because they are positive.
You want to teach or I teach? Okay. They're giving out electrons to combine. So when they give out electrons, what will their charge be now? Positive. All metals are positive. Why? Because they donate electrons and electrons are negatively charged. So they're giving out the negative charge, so they become positive. So all metals are positive. All metals are basic in nature. That you have to remember for the rest of your life and my life. Remember that metals are basic and metals are positive. So group 1 gives out 1 electron. Group 2 gives out 2 electrons for combination. Group 3 gives out 3 electrons for combination. Group 4 will give out, it will give out or accept, mostly it is accepting because that is group 4. Right? Pardon. Transition elements is not in your course, that comes in lower down. We don't talk about the groups, transition elements. We just go by simple 1A, 2A, 3A, AAA groups. And I'm teaching you the periodic table. I'll explain to you the difference between A and 1, 2, 3, 4, 5, 6, 7 until 18. That explains you later on. Group 5. Now, group 5, group 6, group 7, group 8. These are all non-metals. They are accepting electrons. So they become positive or negative? They become negative. So their valency is positive or negative? Negative. Minus sign. Now, in the case of group 5, what will be the valency of group 5?
Negative.
Give me the number. Group 5. I'll give you a clue. If it is after group 4, this is a rule that you have to follow. Group 5, it will be 8 minus group number. Why Because you need 8 electrons for complete stable configuration. So 8 minus 5, 3. So the valency of group 5 is 3, negative 3. Then you go to group 6. 8 minus 6, negative 2. 7. 8 minus 7, negative 1. And the last one, because they don't accept anything, is 8 minus 8, 0. They don't accept. So the valency is 0. Followed? This is all clear now. From 5 onwards, you have got non-metals. Their valency is negative because they're accepting electrons. And what is their valency? It is according to 8 minus group number. 8 minus group number. Correct? This is clear? As for the periodic table, the valency, what is the difference between valency and valency electrons? What is the difference between valency? Have you heard of this word valency? Yes. Have you heard of valency electrons? What is the difference? Tell me. What is the difference between valency and valency electrons? That's where you make a mistake. Yeah?
Valency is the combining capacity.
Yeah.
And valence electrons are the electrons in the outermost shell.
Very correct. If I say this is 9th standard children, that means children in the 9th standard. So if I say that is, these are the valency electrons of 8 group, that means there are 8 electrons in the 8 group. Valency electrons are the number of electrons present in the valency shell. Valency electrons are the number of electrons present in the valency shell. Like 9th standard children are the children present in 9th standard. Correct? So 1 valency plus 1 valency is the valency present in group 1. Group 1, group 2, group 3. The valency and valency electrons is the same. Am I right? Am I right? Well, in group 1, group 2 and group 3, the valency and valency electrons is the same. Correct? Group 1, valency electron is 1. Valency is also 1. It gives out 1 electron. Group 2, how many valency electrons are there? Group 2, how many valency electrons are there? 2. What is the valency? 2. Group 3, how many electrons are there in the valency cell? 3. What is the valency? Group 5, how many electrons are there? How many electrons are there in group 5? How many electrons are there in group 5? What is the valency electrons in group 5? Valency electrons means number of electrons in the valency shell. How many are there in group 5? Huh? You're asking me or telling me? Telling me. Well, how many you said? So what is the valency then? 8, 8 minus 5. Correct. Now you know the difference between valency and valency electrons. Valency electrons are the electrons present in the valency shell. Valency is a combining capacity. Group 1, group 2, group 3. Valency electrons. Valency is a shell. Group 4, 5, 6, 7, 8. Valency electrons are the ones according to their group. And valency is 8 minus group number. Who has not understood this, raise your hands. Who do not understand this, raise your hand. All of you understood, so I don't have to bother about valency. Now, in case, and I said also before that it also depends upon how that element combines with oxygen or with hydrogen, correct? With hydrogen or oxygen. That is the old cell. So if you have water, you have got oxygen combining with hydrogen and combining with hydrogen. So oxygen combines with 2 atoms of hydrogen. So oxygen valency is 2. Correct? Now, carbon combines with 4 atoms of hydrogen. So carbon's valency is 4. So depending upon how the element combines with either oxygen or with hydrogen, you calculate or you get the valency. But all said and done, we bother about the number of electrons that are donated or accepted. That is the valency that we calculate. Is display? 7:30. We have a break, no? 1 hour. Continuously, we don't. I can't talk. Huh? I need a 5 minute break. I'll die. Okay. So we finish the balancing. Okay. Now there are certain elements that have got variable valencies. Variable means more than one. Like for example, in the case of copper, these are the few ones that you have to remember. Copper. I'll write on the symbol copper. Okay, then you have got your SN. SN is tin. Tin. This is copper. Then you have mercury. Okay, then you have got you've got phosphorus or lead, Pb, plumbum. This is lead. Okay, now copper. Now you've got then you have got iron. You've got iron, no? Iron. Now iron, you've got two valencies. Okay, it has got valency 2, it has got valency 3. Copper has got valency 1 and valency 2. Tin has got valency 2 and valency 4. Mercury has got valency 1 and valency 2. And lead has got valency 2 and valency 4. Now, if the valency is smaller, it goes as OUS. Cuprous, OUS. Ferrous, OUS. Then stannous, okay. Mercurous. Okay, and here you come to plumbum. Okay, plumbum. So you can say here you have got lead. Lead will be +2. Okay, lead +2, OUS. Plumbus. And if it is for plumbic, mercuric, stannic, cupric, ferric. If it is smaller, it is OUS. If it is bigger, it is IC. Plumbus, plumbic. Ferris, ferric. Cuprous, cupric. Stannous, stannic. And so on. Is this clear? So we stop till there. Okay. Now, okay. What is okay? So I told you that metals are acidic or basic?
Basic.
So that they are called basic radicals. And non-metals are acid radicals. So what is a radical? Big word. I'm using big word.
It's an atom or a group of atoms of different elements that
Have a charge.
the charge.
What is it? So, what is a radical? A radical is one atom or a group of atoms which has a charge. So suppose you have got one atom here, sodium. It has a charge. This is a sodium radical, monoradical. Correct? If you have got, say, for instance, here you have got hydrogen. Say hydrogen 2. All right. 2 atoms of hydrogen. Okay, so you have got, say, and it has got your, so you said plus 1, but there are 2 of it here. So then this becomes a compound radical. When it is 2, this is 1, it's simple, it's mono radical. When there are 2 atoms, it is said to be a compound radical. Okay, and if you have a compound radical, and if you have got many sulfate, you've got sulfur and 4 of oxygen. So this is said to be polyatomic radical. This is -2. Don't bother about the -2. It is a negative, but you have got more than 1 atom. When there is more than 1 atom, it's called poly. If it is 2, it is called compound. And if it is 1, it's just mono. Just simple. Followed? Any difficulty? Raise your hands, anyone who's got a difficulty, who's not understood so much. I won't go further. Read till what I have taught you now. Then I'll come back and continue with. Right now, have you got your textbooks with you? What textbook are you following? Selina? Selina? Dalal you're using? Podar was using Selina. Since when has Podar changed to Dalal? Huh? From the very beginning. From the very beginning, right up to valency. Simple radical compound. I'll give you my book, no problem. What book are you following? Dalal? Okay, Dalal you're using also. You're using Selina. You are not following. You, Selina, Dalal. You, Selina. How many using Dalal with your hand? Okay, no problem. You can use it in a, and if you find it difficult, then you can take a Selina book with you. Is this clear? Any part of Dalal which you have not understood, immediately put your hand up and then we didn't understand this. Please explain to us. I'll explain it to you. Okay, read now. From the beginning. Now pay attention on, in the case of Dalal, this is Dalal book. Such an old book it is. New book of Dalal. You have got on page 1, they have given you symbols and they've given you the names. We learn by heart. And not orally, because you'll never forget. You'll never remember. Chemistry is very volatile. It will go into the air. Write it down. Each one is written down at least 3 times at home. And don't write down copper COPD or and keep on talking and looking at the TV. No. You focus or you forget it. Don't do 2 things at one time. Chemistry is not to be taken lightly. This is clear. Then don't this. I can't understand balancing of equation. I can't understand this. I can't understand that. If you don't know the symbols and you don't know the names, you will understand nothing. Have you understood? All of you. That will be learned by heart. Similarly here, variable balances.
Can you
What?
repeat?
I said that in your books you have got a lot of, even in the case of what should I say, Selina. You have got Selina, open up your Selina book. You have got on page 2, page 3, Selina, page 2, page 3. You have got page 5. You have got all the names. Page 7. You have got names of radicals, names and symbols of elements, names and symbols of and formulae. All that can be learned by heart. Variable balancing, positive balancing, negative, how many plus 2, plus 3, all that is to be learned by heart. Because we have to do now how to write down a chemical formula. If you don't know the valency and if you don't know the symbol, you will not know how to write a chemical formula. Similarly, in the case of Dalal. Dalal also, you have got page 3, page 2, then you have got page 5, then you have, page 3, 5. All those elements to be learnt by heart by writing them down. Start practicing your habit of inculcating or establish a habit of writing. No oral work. Chemistry is not an oral subject. Is this clear? It is to be written down. Everything. So read now from the very beginning until we come to balancing. And I'll come back and I'll teach you how to write a chemical formula. Huh? That sheet you don't have to write down because you all are always. You're a demo child. Sit. I didn't hear you. Isha. I only know Subha ma'am. Subha, because she was a teacher we had. I teach like her. She was she's still there in India. Yeah. Pardon me?
Which mom?
Shubha Rao. Shubha Rao. She's a yes.
Yeah, she will teach her.
Ninth and tenth.
No, she's teaching.
Maths they teach you. Physics.
Oh, yeah.
Very good teacher.
She's still here. Actually, teaching.
Okay, otherwise there will be some everything.
Chemistry teacher.
No, no.
No, because he teaches like.
I seem to be teaching like all the teachers are not following.
Yes.
To teach you nice skills. That is anti-teachings. Of course. No, that's that. Any difficulty, ask. Don't hesitate to ask. Please, children. Don't be afraid. Because I'm not a monster. Of course, you will say I'm a monster. But don't bother about it. Don't ever listen to what he has to say. We have started with the English in school. We want to start with Caesar, or you have started with the West very first poem.
Work of art.
What it started?
Work of art.
You started already?
Yeah, and a short story, Monkey World.
Both your since when they are so fast they are finished.
No, they are continuing with the Monkey World.
Yeah. These are the simple, but they will not come. What happened is in before they started giving them names, giving copper, cuprous, okay, they gave them symbols, okay, and then they found that the symbols were limited and the elements were continuously being discovered, so they scrapped off that method. Then they said give them the English name, that was scrapped off. Few elements were given the English name. Then they said let's go for the Latin names. Again, that was only for certain elements. After some time, they said we'll give them by the color. We'll give them by the country from which they were obtained, like Argentinian, okay, silver. All right. So like that, various methods, various parameters they use to give a particular element its name. Okay. So these are just trial and error methods, you can say. next Friday, okay, I want to see your writing down of all the elements, okay, all the valencies, all that is there, okay, color, OUS, IC, all that you written down and shown to me. Don't ever say, Miss, I forgot my book at home. Or don't say, Miss, my favorite cat came and stole away the book. Or my goat has come and chewed my homework. That homework only which you gave it, the goat has chewed it. You give me those type of excuses. God help you. God help you. So, okay, I come back from there. Then I can share. Now, see, for example, you have got the atom, you've got the nucleus here, you've got the first shell, you've got the second shell, and you know that first shell contains 2 electrons, the second one contains 8, and it goes on and goes on, okay? The third shell, okay? And the last shell is said to be the valency shell. The second last shell is called the penultimate, penultimate. Second last shell is called the penultimate, okay?
Outermost is called
Huh?
the valence.
Huh?
Outermost shell is called the
Valency. Outermost shell is called the valency shell.
and the one below is
Penultimate. Penultimate shell. Valency shell is the last. Penultimate is last but one. Last but one. Ah, okay. Let's come back. You can take a break, huh? Don't sit and read. Take a break.